All right, my name is Gary. I work for the University of California Agriculture and Natural Resources, and also for the University of California Cooperative Extension. And today we're going to talk about plant nutrition for nurseries and for greenhouses. And I got books here, pass them around and look at them because there is a lot of the symptoms of nutrition deficiency and toxicity are very visual. They're very fun. So it's they're better conveyed with pictures than with words. Although I'm going to show you some slides, but and they're very typical. When you teach yourself how to recognize them, they have a very obvious pattern. And I want to thank Dr. Dodmer Hott that many of these slides are from him. And if you are on Zoom, please change your name. Make sure that we get your first and last name. So then later I can send a list of participants to Tasha so you can get credits for the irrigated lands group. And on that note, thank you, Tasha, and thank you, Ariana. I show up here looking wonderful, and I talk to all of you, but they do all the hard work behind the scenes to make sure that the whole system works, and they give me the opportunity to serve you. So I want to make sure. I want to thank these ladies. They're very helpful. And Tasha runs the dashboard. We call it dashboard. I don't know why Windows moved the T down here, but we call it dashboard. The T is up there because Tasha runs it. And if you don't want to miss any of these seminars, sign up for email updates here, and you get the emails from me of all the things I do. Hey, Lee, welcome. Always late as usual, But the reason why Lee can get here late and still eat a burrito and still have coffee is because CDFA with the WETA program supports us. So thank you, CDFA. Thank you, CDFA. They give us some money so we can all do this. So it's the WETA program and CDFA, thank you. And also thank you for the Farm Bureau. They give us this room so we can have these seminars, and both the San Diego and the Los Angeles Irrigated Plant Group. They help us. So now that I've bored you to death, now you're sleeping already, what are we going to talk about? Plant nutrition, macronutrients, micronutrients, many of you know already. NPK are the fertilizers, but there's a trick, right? When they say 20-20-20, it's not really 20% of nitrogen, 20% phosphorus, and 20% of potassium. There are some coefficients there. We're going to talk about pH. How many of you regularly measure pH in your plants with a machine like this? What range are you looking for? Fred?
0.8.
6.8, okay. We got the 6.8 over here.
5.5 to 6.8.
Any others? Any others?
5.
The same? Very good. Very good. So you want to be around 6. You want to be around 6, 5.6 to 6.4 in general. But then we'll try to qualify this answer a little better. And then we're going to do a pour through. How many of you do pour throughs? So the pour through is a very simple method where you put a plant on a pan like this, and you pour some water through, but there are some tricks to make it right. So at the end, if we still have time, we're going to do it. And notice that I have here a pansy and the geranium and the zonal geranium. So there's a reason why I have these two different plants, and we'll see later. And then you collect 50 milliliters of water in that pan, and then you measure the pH and the electrical conductivity with one of these machines. So any questions?
No.
All right, what's in a plant? If I take this plant and I send it to the lab and I tell them, tell me what's in it. What do they tell me? You guys are bored already.
Carbon.
Carbon, yeah, that's on the dry matter, right? The dry matter is mostly carbon that plants fix from the air, but 80% of it, 90% of it is just water. So if you drew, and I do that all the time, I take some samples of plants, I grow plants, I take the samples, I weigh them, maybe the plant weighs 200 grams, and then I dry it. And then when it's completely dry from the oven, I weigh it again, it weighs 2 grams, right? So it shrinks like 90, it loses 90% of its volume. And then the minerals are only 3%, 3 to 10%, right? So it's a very small component, like nitrogen, that is the one that has the highest percentage. Who knows how much nitrogen on a dry basis is in a leaf? 10%, 20%, 30%?
Yeah, 1%.
Fred says it can't be more than 1% on a dry basis, on a dry basis. Who knows? If you don't know, it's fine. So on green leaves like this, very young, very succulent, you're looking at 4%, 5%. On a leaf of a tree, maybe is lower 1 or 2%. Nitrogen on a dry basis, right? So it's very little. It's very little. Most of it is carbon, like Eric said. So of this little slice, what is composed of? As I just said, mostly nitrogen and mostly potassium. These two are the biggest in terms of quantity, quantitatively. And I want you to notice how small is this slice of phosphorus. Uh-oh. Hello, hello. Can you hear me from home?
Yes.
All right. Phosphorus is really small. Got a small slice. And then everything else, calcium's got a big slice, relatively big, and then everything else is relatively small. And this is why you see calcium and magnesium. This is why we put dolomite in our substrate. So we increase the availability of calcium and magnesium, and we also raise the pH of peat. But I have a question for you. The number that you find on the fertilizer refers to nitrogen, phosphorus, and potassium, right?
Yes.
17, 5, 17. And this other one is 10, 30, 20. Which one do you think is balanced? What's a balanced fertilizer? Considering that in a plant, if I take this leaf and I send it to the lab, they tell me, look, there is between 2 and 6% of nitrogen, there is 3 or 4% of potassium, and there is only 0.2% of phosphorus. Which one would you use? This one that has a lot of nitrogen and potassium and very little phosphorus, or this other one that has a ton of phosphorus in it? You don't need a lot of phosphorus. You don't need a lot of phosphorus. Even a 20-20-20 is not balanced. 20-20-20 is not balanced. Are you with me from home?
Yes.
Do you agree with me?
Yes.
So plants need nutrients, but they can get even too much, right? If you give a plant too much, it's like when I go to the all-you-can-eat buffet, and there is too much shrimp. I overeat the shrimps, and I hurt myself. The next day, I feel terrible. So that's known as toxicity. Toxicity. So plants can absorb too much of a nutrient, so much that they hurt themselves. And this zona geranium is a good example. Who knows what's toxicity that plant suffers of classically? All right, we'll learn it later. And instead, if the availability of a nutrient is low, obviously you get deficiency. So I want you to learn this difference between mobile and non-mobile nutrients. Who know this? Who knew this before? Which nutrients are mobile? Oh, it's written there. Who knows without cheating? Who wants to tell me without cheating? Maybe never. Maybe. So it turns out that NPK, those three that we know from the fertilizer bag, and also magnesium, those are mobile. So let's say that we are all in this room and we are a bunch of grown-up, we're 10, and there is only one burrito. We're all hungry. There's only one burrito. And then there is a 5 years old that is super hungry. Who gets the burrito? Who do we give the burrito to? Lee, right?
Gets the win. Put a out.
So, when you can move nutrients, you give them to the young leaves that are growing up. The plant mobilizes, if it can, it takes all that nitrogen and moves it up to the young leaves, right? Because I want to grow. I want to make some flowers. I want to reproduce, right? So the old leaves, well, they'll have to die. They'll have to yellow, and sometimes they'll liver drop. And so this is a trick to remember that these four nutrients, here, and maybe these two also, I'm not sure, but these four nutrients, certainly you see the deficiency on the older leaves. Does it make sense?
Yeah.
Did I go through? This is a great example. Last week I visited this greenhouse. They're growing these tomatoes in slabs, and all the older leaves are all yellowing. Because the plant does just that. It moves the mobile nutrient up to the top, and is actually trying to flower here to make some fruit. Questions from home? Conversely, immobile nutrients, the plant physiologically cannot move them from where they are in the leaves. And so the young baby needs to grow without nutrients. And so the deficiency symptoms of the immobile nutrients are shown in young leaves. Does it make sense? So with this trick, you have a jump start with your diagnosis of symptoms. Who's convinced? Who's just had a major haha moment? Okay. Okay. So again, the macronutrients are again NPK. P is phosphorus and potassium is K, right? Don't get confused. NPK is nitrogen, phosphorus, potassium, sulfur, calcium, and magnesium, but I put the immobile on this side and the mobile on the other side, just to drive the point home. So sulfur and calcium are famously immobile nutrients. And in fact, who knows an example of calcium deficiency?
Curled leaves
Curled leaves where?
on the old, the new leaves, they curl up
Thank you.
like a strawberry.
Thank you. Tip burn. Tip burn is another one, right? The tip where the plant is growing, these young baby leaves don't get enough calcium because the plant can't move it from the older ones.
I did not know that. Did you know that curling leaves on new leaves?
All right. So where do you think, well, now I just screwed up my question. Where do you think that calcium deficiency appears? Again, in young leaves, right? Tip burn. And another one on tomato is the blossom end rot, right? On the very top, on the very tip of the young fruits. Again, so the macronutrients are NPK, sulfur, calcium, and magnesium. And if you're into this stuff, you can learn this super complicated phrase that will help you to remember what the macronutrients are. I have no idea who Nancy Peterson is, but I'm sure you do. And again, mobile, immobile, and then we also have micronutrients that are a lot of other weird stuff that I'm not going to bore you with. Many of them are metals, and they are in enzymes. They help enzymatic reactions, but in the floricultural industry, we kind of treat them all in once because the product the products for micronutrients typically come all together, right? So if you call a rep like, hey, I have a nickel deficiency, like, oh, okay, I'm gonna send you a bag of STEM or Micromax, or I don't know which one, right? And then the next thing you call another one, hey, I have a copper deficiency, well, Micromax. Oh, I have a nickel deficiency, well, STEM, right? So the answer is always the same, unless you're making your own. Unless you're making your own, right? So those are the macronutrients. And now I want to focus on the deficiencies of each nutrient. And nitrogen is the most obvious. Plants are yellow. These are two marigolds that I grew with high nitrogen and with low nitrogen. And then I took a picture of one next to the other. You see how light green this one is and how nice and dark green that one. Same plant, same age, same seeds, same everything. So this is my picture. And these are the classical pictures that you get on the book. But I want you to notice these leaves here. Why are they dying? These leaves here. Are they young leaves or old leaves? Old. Why are they dying? Because the plants took the nitrogen from these plants to move them up to these leaves, to move them up here so these younger leaves could grow. Does it make sense?
Yes.
Okay, so if you get a bag of 100 pounds of 20, this is very simple. It's got 20% of nitrogen. So if you want to go through the numbers, you will take 100 pounds of fertilizer of 20. It's got 20 pounds of nitrogen in it. Very simple. If you have 100 pounds of 20, it's got 15 pounds of nitrogen in it, right? And if you get 50 pounds of 20, it's got 10 pounds of nitrogen in it. It's very simple. You multiply the pounds by 10% or by 20% or by 15%, right? Are you convinced? So nitrogen is nitrogen. These numbers that they give you here when they say 20 is actually nitrogen. Is actually nitrogen. Let's talk about phosphorus. How many of you have seen phosphorus deficiencies? All right, on what? On what plants?
Urios.
Oh, okay.
Yeah.
What does it look like?
The bottom leaves are all red.
Oh, okay.
Yeah.
So the reddish purplish color is very indicative of low phosphorus, and also the green is darker, and the plant is stunted. You see, this plant is shorter and darker, and but typically in greenhouses and in nurseries we tend to over apply phosphorus. So chances are that your problem is the opposite. But again, the symptoms are this: purpling, reddish, violet leaves. Okay, if you get a bag of 20, does it have 20 pounds of phosphorus in it?
Hey, what's up?
It doesn't. It doesn't. It's
What's that?
20% of
There
phosphate.
might be a couple left back there.
Phosphate, not phosphorus, right? Phosphate is this compound that has some
1250,
atoms of
and we only have
phosphorus in
20.
it, but also a lot of oxygen. And those oxygens are heavy. So it turns out that
Only 10.
only 43%
Over there,
of
40, 40.
that phosphate is phosphorus. And as a result, those 100 pounds of fertilizer, they're not 20 pounds of phosphorus, they're only 8.6. Because you take those 20 pounds of phosphate and you multiply by 0.43. Does it make sense? I always use this joke that I go and I buy a chicken and then I go home and I remove the head of the chicken, the legs, the bones, and I end up with only 40% of the meat, right? So the meat, your phosphorus is the meat. There is only 43% of meat. So really, if you go to Europe, believe it or not, that 20, they call it 28.617. Because they tell you what the actual phosphorus is in it. They don't cheat. They don't cheat with this phosphate thing. So again, 43%, right? 20 pounds by 43% is 8.6. 15 pounds multiplied 43% is 6 pounds. And if it's got only 50 pounds of fertilizer, then it's 4.3 pounds of phosphorus. So be careful, be careful. There is also a video on YouTube. My friend, Dr. Paul Fisher, is a legendary professor at the University of Florida. He's got this video on YouTube where very convincingly he showed that a lot of research saying that you don't need more than 20 ppm of phosphorus. So if you have liquid feed and you're pumping 50 ppm of phosphorus or 100 ppm of phosphorus, chances are that you are wasting a lot of money and a lot of phosphorus. So you find this video on YouTube if you're interested about phosphorus. And the reason why we push so much about phosphorus is Eric's favorite, the water quality regulations, right? And all the bad things that happen when we apply nitrate, nitrogen, and phosphorus. What does potassium deficiency look like? Who has seen it? I've seen it in lettuce. You get this very regular yellowing and kind of burning on the edge of the leaf. But it doesn't look very nice. You see, it's not very regular. It's all over the place. Other symptoms that we'll see later are very symmetrical. They look very nice. Look like somebody painted them. These are not. So you get yellowing and necrosis on the edges. Again, I'm gonna bore you with potassium. The secret number is 83%. Again, because this 20 doesn't refer to potassium, but refers to potash, K2O. And potash has 83% of potassium in it by weight. So again, those 20 pounds, you multiply by 0.83, you get 16 pounds of actual potassium, and 12 pounds and 4 pounds. I made an Excel spreadsheet for those of you that use dosatrons, or I should say fertilizer injectors, whether they're super dose or they're mixed right, or they are, what did I do? Or they are dosatron, it doesn't matter. Or if you use a Mazzi, you can use a Mazzi. Why, what did I do? What did I do? What did I do? Better? All right, I fixed it. Yeah. So if you inject fertilizer, if you inject liquid fertilizer in your irrigation system and you use what we call liquid feed, you can download this spreadsheet that I made for you and you just punch in. You see, you only punch in on the white cells. The gray cells, you leave them gray. And you say, oh, I'm using 17,517, or oh, I'm using 20,10,20. You punch it here. And then you say, oh, I'm using 1 pound per gallon in my big drum, in my big bucket here. And I set the injector at 1 to 100. So if you give me these numbers, I only need those 5 numbers to tell you what's the ppm that you're injecting. You don't seem very impressed. Is this enough? Is this enough? 26 ppm of phosphorus? Yeah. It's plenty. It's plenty. You don't need more than that. You don't seem convinced, Fred. so you can, back in the day, there is somebody should write a book about horticultural mythology. So back in the day, there was this, people were saying that you need a lot of phosphorus to grow nice roots, and that you need a lot of phosphorus to grow nice flowers, right? Now, while it's true that if you have phosphorus deficiency, then you don't get flowers. The other way around is not true. It's not that you over apply phosphorus and you get a lot of flowers. Does it make sense?
Yes.
So 20 ppm are plenty. 20 ppm are plenty. Yes, sir.
Point. Speaking as a distributor,
Yes, sir.
phosphorus is the most expensive element in a fertilizer bag.
All right.
Most of our phosphorus currently comes from Canada. And because of tariffs, they have raised the price of phosphorus extremely high.
Can you hear from home what Lee said?
Yes.
All right.
So it is very expensive phosphorus. So I have a hard time when people want to buy high phosphorus fertilizers. It's a waste of money, big time.
Huh.
Waste of money. Yeah.
All right. Thank you. Thank you for that. So you can download this spreadsheet. There is a code there that you can scan, or you can just email me and say, "Hey Jerry, I have trouble sleeping. Why don't you send me your Excel spreadsheet? I have time. I finally have time to look at it." Now this is not working anymore. Why are you not working anymore? Okay, calcium deficiency. This is the tip burn that Lee was talking about. You see these kind of looks burnt and kind of deformed. And that's the blossom and rot that we were talking about. So calcium, again, it's an immobile nutrient and you get symptoms at the very tip. And I'm sure that there are some nice pictures in that book too. Why you don't want to be helpful. And magnesium deficiency. So this professor here at North Carolina, his name is Brian Whipker. He's really cool with all these deficiency symptoms. So I want to thank him and acknowledge his contribution. And those books are from him. And this is magnesium deficiency. Where do you think that we get magnesium deficiency? On old leaves or on young leaves? Oh. Why?
It's your hands covering it up.
It's mobile? Because it's mobile. Because it's mobile. So the plants move it from the old leaves to the young leaves. And so you see it very clearly here on these chrysanthemums here. And the nice thing is that you get these very typical symptoms that looks really nice. Very regular, very symmetrical. And we know, who knows what these symptoms is called?
Yeah, Christmas tree, but good.
Chlorosis. Chlorosis means that it gets yellow, but this is called interveinal chlorosis because the veins remain green. Can you see? So this is a typical symptoms that we see in magnesium, and we also see in iron. We'll see it in a minute. So learn how to recognize. This is my picture on coffee. On old leaves of coffee, this was magnesium deficiency. And you see, it's interveinal chlorosis, and it looks very obvious, right? Those veins are still green, and in the middle is yellow. Conversely, iron, who remember, is iron mobile or immobile?
Immobile.
Where do you get the symptoms, on young or old leaves? Young leaves. And it turns out that you get interveinal. Turns out you get interveinal chlorosis on iron too. So the only way to tell it apart is whether it's on young or on old leaves. Hey Jerry, I have a problem. I'm getting interveinal chlorosis on my petunias. What do I do? Right, and I answer, well, is it on the young leaves or on the old leaves? And if it's in the young, then it's probably iron, and it's the old leaves, it's probably magnesium. Does it make sense?
Yeah.
Who just had a major ha-ha moment right now? Okay, nobody? Okay, good.
I would pay for my burrito.
It's okay.
And here, and you see very obvious, these are some zinnias that I grew. And we're gonna talk about in a minute about the reason that caused this low availability of iron. But you can tell very obviously that the young leaves don't have it, and the old leaves have it.
109.42.
Say it again?
Feedback.
Oh, it wasn't for me? Okay, let's keep going. Now I want to talk about concentrations. What's a ppm? What does ppm mean?
Hmm.
Part per million. What's the difference between a ppm and a milligram liter?
Same thing.
It's almost the same thing. For all intents and purposes, it's the same thing. Because in 1 liter, there are 1,000 milliliters. And in a milliliter, there are 1,000 microliters. So a milligram per liter is like saying a part per million.
How many you need?
I usually one for now. Because 1 liter is a kilogram, right? One liter of water weighs
Okay.
1 kilogram. So in 1 liter of water, there are 1,000 kilograms, and there are 1,000 grams, and 1,000,000 milligrams. Did I convince you? Vaguely enough?
Yeah.
Vaguely enough. So instead of part per million, you could say milligrams per 1,000,000 milligrams of solution. And it turns out that 1,000,000 milligram is a kilogram. And it turns out that the kilogram of water is a liter. So if you don't understand it, I do that all the time, accept it. If you can't understand it, accept it. And so learn how to accept that these two things are equivalent as long as the concentration is very diluted, which it is with fertilizer, right? Because we're assuming that the density of the solution is similar to the density of water, which is
I
one.
just sent you an email. I need to check.
Okay, I see confused faces. But you can use ppm to measure any salts dissolved in water. And you can also use it, and Bruce does that all the time, to measure what we call TDS. What's TDS?
Without salts.
Say it again, say it again.
Without salts.
What do we use it for? Why is it useful?
Salt water.
Say it again, say it again, say it loud.
The salinity.
That's right. We use it to measure, it's a measure of salinity. Total dissolved solids is a measure of salinity. So you can measure this water, you can buy this water at the grocery store and say, oh, are they screwing me? Is there a lot of salts in it? Let me measure. Let me measure how many total dissolved solids are in it. Oh, there is 300 ppm of total dissolved solids. It's not very salty. Good. It's a good deal for $2. Does it make sense? Or maybe you go to my place, you open the tap, and you get 600 ppm of total dissolved solids, and still they charge us a lot of money for that. So the utility company is screwing us because they give us very salty water for a very high price. Or maybe Lee has a client that's got a well, right? So they can measure TDS in the well, right? Other folks measure salinity in terms of EC, electrical conductivity, the Siemens per meter, but the two things are equivalent, right? Does it make sense? So ppm, sorry. ppm of total dissolved solids is, you can say, I have 15 ppm of phosphorus, I have 200 ppm of nitrogen, but you can also say I have 300 ppm of total dissolved solids. It's the sum of everything. Everything that's in the water. Carbonate, sulfate, all the junk, chloride, all those bad things that we don't like. Sodium, does it make sense? More or less? I am struggling with this thing. I am struggling with this thing today. I don't know why. Okay. Which brings me to electrical conductivity, which is a trick that we use, and Bruce loves that machine because his is really good one, and instead I have the cheaper one. It's a machine that measures how well electricity, water conducts electricity through it. And if you go on my website, on my YouTube channel, I have this demonstration where I have a lamp and a 12-volt battery, and I put both leads in a basin with water, and the bulb is off. And then I put a handful of soluble fertilizer in it, and I start mixing the water, and the lamp turns on. Because putting fertilizer in the water increases the electrical conductivity, and now more electricity goes through the water, and that's the reason why the bulb turns on. So whether I convince you now, or whether I'm gonna convince you when you watch the video, or whether I will never convince you, just accept that this machine measures the ability of water to conduct electricity, which turns out is linearly related with the concentration. So this machine is a cheap trick to measure the salinity, the total dissolved solids in the water. Now, what happens if I take a sample?
Can we have
And-
English open for Florence?
We're going to get the joint car.
We need to run out.
What happens if I take a sample of water from the well that Lee has,
Oh, I sent you an email with a few other check.
and they've got 2 decisiemens per meter, and then I add deionized water to it? What happens to the concentration? It goes down because it gets diluted, because the salts are still there, but I double the amount of water, right? So now the milligrams per liter, the milligrams are the same, but the liter is doubled. So the concentration went down.
אתה אומר,
Doesn't
לפתוח
make
את המים מחר?
Be very careful with
היום
dilution.
78, מחר 79.
Okay.
אה?
How do you mute? How do
יום
I
שני?
mute?
כי אנחנו לא נהיה פה שישי ולא חמישי.
לא תהיה, נכון?
שבת הם יהיו פה. לא נפתח.
So, and the relationship is this. The Siemens per meter, many of you talk about the Siemens per meter because that's what you get from that machine. And in the well, you will get 1.5, 1.7, right? You will get numbers like this. Some of you talk about like Bruce.
מגיע.
So Bruce will tell you, oh, I've got 1,000.
Yes, on the right side.
It's worse on the right side.
Yes.
Is it going down your leg or is it just in your low back?
It's going down. Hold on.
Can you unmute from home, if you don't mind?
Okay.
Thank you. And did I convince you? So sometimes you talk about ppm of total dissolved solids, and sometimes you talk about EC, but the conversion factor is 640. So if Bruce and Lee talk on the phone, like, hey, did you measure the salinity in that well? Yes, it's 2 decisiemens per meter. And the other guy says, no, actually, I measured 1,300 ppm. And the other guy says, no, it's actually 2. And the other guy says, no, you're wrong. It's 1,300. So they're both right. They're both right. Does it make sense? So don't get confused. And if you do, I'm only a phone call away. My job is to keep these things clear in my mind so you don't have to. So please ask, please reach out. pH is the weirdest thing in the world. It's the weirdest thing in the world. It measures the molar concentration of hydrogens in the water, which is kind of a confusing concept in itself, but it's a logarithmic scale. And as a young student, I could not wrap my head around this thing. Every time that you dab
Go
to,
also on the butterfly bush.
every time that you
Santa Luisa,
increase by 10
Ruda
times the
Nuevo. Get the
concentration.
salvia blue next to the butterfly bush, the big,
You
and water that stuff, okay?
Let me see if I can mute these guys. How do I mute these guys?
Me?
I want to hear about the salvia,
They
actually.
have to mute their microphones.
How do I mute these guys? How do I mute these guys? Check this
I'll
out.
mute myself.
I'm muting everybody. Apologies. I'm muting you all.
Yeah.
I'm muting you all. But please unmute yourself and talk to us if you want to. Okay, I mute everybody. But Mary, don't let me forget that you want to talk. I should have let it up at the beginning. So pH is a concentration, but every time that it increases 10 times, it changes by one level. As if I have some coffee and it's extremely bitter. It's extremely bitter. Let's say that I have some levels of bitterness. Extremely bitter, very bitter, bitter, a little bit bitter, neutral, little sweet, very sweet, extremely sweet. I start from this coffee that is extremely bitter, and I put one spoonful of sugar, and from extremely bitter, it becomes very bitter. And now, if I want to change it from very bitter to bitter, now I need to add 10 spoonfuls of sugar. And now to change it from very bitter to bitter, I need to add 100 spoonfuls of sugar. And now from bitter to neutral, I need to add 1,000 spoonfuls of sugar. It's exactly the same. Every time that you change one step more in that scale, it takes 10 times more. Does it make sense? It's called a logarithmic scale. And it's the weirdest thing in the world. To me, it's just weird to conceive it. It's just weird to consider, but it's exactly like the example of coffee that I described. But for all intents and purposes, all we need to do is just being able to measure it and to know what range we need. Does it make sense? More or less? From home? Okay, so there is this website, again, from the guy at North Carolina State, that they choose the weirdest name for it. And I suggest you do not Google it. Do not Google it because some weird stuff comes up. Also, because then Google says, "Oh, did you mean feet? Did you mean feet?" And so then the combination of those three words together produces some weirdness. So just punch it in without Googling it, and you will find all these fact sheets. All these fact sheets, and whether you're growing Calibraco or Coleus or whatever, Celosia or whatever you're growing, you click on it, and they show you this kind of sheet with data, and they tell you what they see, what the electrical conductivity that you want, and what the pH category. You see 5.5 to 6.5. So for all the floricultural crops, this is a very useful resource. And now I want to tell you a story about petunias and marigolds. Turns out that petunias, who wants to tell me what's the problem with this petunia?
Iron deficiency.
What kind of deficient? What kind of
IPH is the problem.
Iron.
Well, so Fred just stole my thunder. But what do we know? What does this look like? What did we call these symptoms?
Intervenous chlorosis.
Intervenous chlorosis, right? It's yellow in between the veins and it's still green on the veins. Is it on young leaves or on old leaves? On young leaves, right? Therefore, what is deficiency of what element? Iron. If it had been on old leaves, what deficiency would have been?
Nitrogen.
I got a nitrogen, I got a manganese, and I got a magnesium. And the winner is, who remember that coffee leaves that I told you I took myself the picture? It was magnesium, remember? Remember who remember the four mobile nutrients? NPK and magnesium, right?
Yes.
So the iron is not mobile, and that's why it shows the intervenous chlorosis on young leaves. So petunias and tenses and vincas and a lot of other plants are called iron inefficient. They are not very good at picking up iron. They're not very good at picking up iron, and that's why you see these symptoms. Does it make sense? Now it's gonna get even more weird. Conversely, marigolds and geranium, particularly zonal geraniums, are known as iron efficient plants. They're really good at picking up iron. And they pick up so much if it's too available that they hurt themselves, like myself at the all-you-can-eat buffet. And so you get these symptoms that are bronzing. They're typically bronzing and the leaves get kind of brownish. There are symptoms of iron and manganese toxicity. They pick up too much of the element, of those elements, and they hurt themselves. Who knew this already? Okay. Come on. It turns out, yes, sir. Yes, sir.
You know off the top of your head where citrus is.
No, but I would say general. I would say general group. It's coming up. It's coming up. As many of you know, iron and manganese are more available at lower high pH. Who says low pH? They're more available at low pH. Who says they're more available at high pH? All right, so democracy wins as usual, and they're more available at low pH. What is in Spanish? You see this bar? You see this bar is
I thought it
wider?
was Italian.
It should have been Italian. So here's the trick. Here's the trick. Those plants that are inefficient at picking up iron, you want to grow them at a pH that is a little lower, so iron is more available for them. Iron inefficient plants, lower pH. On the other hand, iron efficient plants, like this geranium or like a marigold, like a lisianthus, you want to grow them at high pH. Otherwise, if the pH is low, the iron is too available, they pick up too much and they hurt themselves. Does it make sense? So now that you're all bored, here's the list. Here's the list of the iron efficient plants on the right-hand side. Marigold, lisianthus, zona geranium. For some reason, I added pentas here. Somebody must have told me. And on the other side, you got the wimps. These are the wimps, right? The wimpy guys that are unable to pick up iron efficiently. So what pH do you need for these guys? When I said low, what did I mean? Did I mean 3?
No.
What did I mean? 5.5 to 6, right? The trick is you're always around 6. Either you're on the low side of 6 or you're on the high side of 6. And where do I grow the iron efficient plants? Do I grow them at 8.5, pH 8.5? No, right? Too high. So when I say high pH, be careful. I mean relatively high pH. The other question is, do I ever grow anything at 7? Is it that's neutral, right? Shouldn't we grow plants at neutral pH? We don't, right? We never grow at neutral pH. That would be too high, right? For everybody. So again, if as a trick, you're around 6, 5.6 to 6.4. Who wants to get the symptoms? So are the veins yellow or are the veins green? What you call this? what did you learn? You call these symptoms?
Fire.
Intervena chlorosis. Is it on the young leaves or on the old leaves? In the young one, right? This old one is still nice and green. This is nasturtium. That is zinnia. And those are azaleas. So what kind of deficiency is this?
Iron or
Iron or manganese? Caused by what? What causes
low pH.
low or high?
Low, sorry, high pH.
Very good. Does it make sense? Did I convince you? So my strategy is they tell you 15 times the same thing over and over again. So at the end, hopefully, somebody will listen. This was for Dana, but Dana didn't show up, so we're gonna skip through it. But if you you grow a hydrangea. No, you don't grow a hydrangea. Who grows hydrangeas in the room? All right. You like to make them blue? No, really? Oh, okay. So some guys, they tell me that they get better price if they make them blue. So there is this race to make blue hydrangeas because they sell better, apparently. The buyers pay better. And so everybody knows that you need to apply aluminum sulfate. But the trick is, if you grow, despite you applying aluminum sulfate, if your pH is too high, they will still bless you. They will still stay pink. And also, if you apply too much phosphorus, they will still stay pink. So the point of this graph is that, sure, put aluminum sulfate, but you need to fix those two things too, those other two things too. Because if your pH is too high and or your phosphorus is too high, and check this out. I mean, it's at 10 to 20. This is not extremely high, right? We said that 20 was as high as we wanted. You can hurt yourself, and I see it all the time. That people tell me, "Hey Jerry, we applied a ton of aluminum sulfate, but some of them didn't want to turn, right?" And it could be due to these two things. And then I was talking about this with Dana last time, and he told me, "Oh, Jerry, you're missing something. There's another thing." And I'm like, "What is it?" And he says, "Well, it's potassium," which I didn't know. I didn't remember. So you want to make sure that your potassium is also high. So you need high potassium, you need low phosphorus, and you need low pH. And then if you have aluminum sulfate, they will turn blue. So make sure that you keep an eye on all these things if you really want them to turn blue. And again, this slide from Brian Whipkers and his students. So thank you, Brian, for letting us use your slides. And here's how you measure it, right? Here I get 4.1, and here I get, what did I get? 7.8. That's how you measure pH. Okay, now that everybody wish they never came and I got only 5 minutes left, we are gonna do a pour through. How many of you want to do a pour through? All right, who has done a pour through before? Who hasn't done a pour through before? Tony, yes, sir. You are our man. So these are two plants. These are two plants that were previously irrigated. Feel how heavy they are. So the first trick is that you want to make sure that you irrigated them this morning. Don't do a pour through when you haven't irrigated for 3 days. Irrigate the plant first. Then you put it on a pan like that. First you wipe off whatever water was in the pan already. You make sure your pan is clean. Can you see from home? Can you see Tony? How
Yes.
do I turn you? All right. So you put your plant on the pan, and here's the trick. Here's the trick. If you see here, which you can't, but believe me, they tell you, look, if you have a 1 gallon container, you need to apply 120 milliliters of water. So you sample at the bottle 50 milliliters. You want 50 milliliters to come out. If you have a 3 gallon, you apply this much, so 50 milliliters come out. If you have a larger container, you apply this much, so 50 milliliters come out. If you have a larger container, blah, 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 50 milliliters. If you have a huge ass container, 25 gallons container, you apply a ton of water. How much water you want to come out? 50 milliliters. So all this table is telling you is that be careful, be careful. Pour water carefully until you get 50 milliliters out of it. How much? Thank you. How much is 50 milliliters? About this much. From home, 50 milliliters is about this much. We all know how much 20 ounces because we go to Starbucks in the morning and we see how much 20 ounces, but this is how much 50 milliliters is. It's really little. It's really little. And sometimes the challenge is that you can get, it's hard to get a vessel where you can dip this thing in only 50 milliliters. Does it make sense?
Yes.
Why am I so anal about you not pouring more water than 50 milliliters? What would happen if you measure the electrical conductivity and Tony here poured a liter of water through the plant? What would happen?
Dissolution.
50% dilution.
It will dilute, right? So if you have 100 milliliters instead of 50, now you would measure half the EC that it actually is. Does it make sense? So that's why you need to be very careful. And people, I tell you this because I see people in the field doing it always wrong, always wrong. And Tony here is going to show you now how deceiving it is. And that's why I bring the squirt bottle. Go ahead. If you use the squirt bottle, it's allowed to go slow. Because what happens is that at the beginning you put some water and nothing comes out. And then you say, well, then you add some more and nothing still come out. And then you add a ton of it, and then now a ton of it comes out. And so it's really hard to shoot for those 50 milliliters. And so you always end up diluting it. And so you always end up measuring a lower electrical conductivity than it actually has. Did I convince you? I don't know. Let's measure it. Can everybody see from home what we're doing? I should have got
Yeah.
it on the. Can you see on this side of the word? All right. All right. Check us out. Man, I'm hired. So maybe we need a little bit more, but not much more, right? Not much more. Does it make sense? So get yourself a bottle like this, or you can steal it from me. I have a bunch in the car. And while Bruce is stealing my coffee while nobody watches, because everybody's watching the pour through. And so, you see we're already over? You see we're already over? Who sees we're already over?
Yeah.
Now, a little bit like this, it doesn't matter, right? We poured maybe 10 milliliters more, but be careful. If we poured twice as much, we would have diluted it twice. Does it make sense?
Should you pour?
We didn't measure it, but you're right. You could use that table, and again, you can scan this code, and you will download this article again from North Carolina State that tells you how much water to apply. Now, if you do it this way, it's a good way to do it, but careful. Not always you will get 50 milliliters out if you apply what they tell you here, right? So it's a good reference point, but sometimes you get a little bit more out of it, and sometimes you get a little less. So don't trust it blindly. And the other thing that I want to tell you is that I use these small saucers instead of these big pans because kind of they force me not to apply too much. Does it make sense?
Yes.
So, yes, sir.
Do you use the water source that you're watering the plants with?
Excellent question. Do we use irrigation water or do we use distilled water? Thank you. The answer is for the pour through, it shouldn't matter. it doesn't matter what water you use, which makes it a lot easier to use the water, the tap water that you have sitting around.
Because that's what you're watering your plants with, so that will add.
But the idea is that if you want to push out only 50 milliliters, what you apply displaces the water that was in the substrate, that they call a substrate solution. And this other one, they call it the displacement solution, and the two don't mix. That's the other reason why I don't want you to apply a ton of it. Otherwise, you mix the two. And so this is why the pour-through method is used a lot. In my generation, we studied, back in the day, we used to use the saturated media extract. That's what we studied in school. You go to the grocery store, you buy distilled water, you add, that's like the soil people do the same, right? You add until it glistens. Who's familiar with the saturated media? That's what we used to do back in the day, right? Then these guys showed up and said, hey, there's a better way. Let's do the
Yeah.
pour-through.
Text me what he took.
Okay.
Right.
And
So the guy took like what, different cactuses or only the one?
And said, oh, pour through this day. Back in the
This
day, we
one?
used to use distilled water, and we used to do the saturated media extract, which I have in this other slide here, which I'm doing in the greenhouse here. You add distilled water until it glistens, and then you squish it out, and you get some water
Which
out.
one?
And another method is the 1-2.
I
that
only
never
approve
use,
him that one.
but some of
You
you
know
may
what?
have.
That's why I said, okay, 30, because I
Most
thought,
diluted,
this
right?
we can make more.
Lot
Yeah.
of water.
Okay.
You add a ton of you add twice as much water as soil
Yeah,
you
the blue
added
ones. I took some of the big ones though, or no?
until
Took
it
some of the big ones
saturates.
though, right?
Does it make sense? And with the pour through, you only add
Some of
water
these.
until
Okay, what I
you
want
get
you to
out.
do right now, before you continue, go cut like 10 pieces.
So,
They forced me to take this web seminar.
so, I wanna tell you why here you get all these numbers, and then I will let you go do something more meaningful with your lives. Check this out. Why these smart guys, why Brian Whipker here tells us, look, electrical conductivity category 1-2 extraction will be in this range. Saturated media extra will be in this different range. Pour through will be in this another range completely. Why does he give us three ranges depending on the method that we use to sample the electrical conductivity?
Dilution.
Say loud.
The amount of dilution.
The amount of dilution. Which one is the most diluted method? Say
2-1.
the 2-1 is the more diluted because we add a lot of water, and so this is the lowest number because it's the most diluted. We added a ton of water. We added twice as much volume of water as the volume of soil that we had, as the volume of substrate that we had. Instead, in the pour through, we added just a little bit of water. Remember, poor Tony was there, like counting the drops? Because I scared the hell out of him, saying, don't pour too much. So we had very little water, and that's why we had the highest concentration, and so the highest electrical conductivity. But I just to drive the point home. Check this out, how different these numbers is. You could be killing your poinsettias if you used the wrong range from the wrong method. Does it make sense? Did I convince everybody or made everybody angry? There's also the plug squeeze method for those of you that grow plugs, that you just take a plug and you squeeze it. And for small containers, this friend of mine up in Half Moon Base, they use the squeeze method for those cypress trees that they grow. And it's similar, you get similar answers to the pour through because it's not diluted at all, right? You just squish it. So we did the hands-on, and I appreciate your time. Sorry, I'm 5 minutes late. Mary has an announcement. Mary has an announcement for